Najah binti Nora Zaiman.
And my name is Nur Fateh Shazwani binti Abdullah. Today we will be present
About recycle process.
As for us, my name is Najah binti Zainuddin.
And my name is Intan Nursafa binti Muhammad Sukri.
So we will be going to present about
Bypass process.
For recycle process, the unreacted reactant will also can be found in the product. So the unreacted reactant can be separated and then recycled back to the reactor, as you can see in the flow diagram. This is the example of recycle process question. As you can see in the flow diagram, the unreacted reactant from crystallizer will be separated and recycled back to the product, which is potassium nitrate. The solutions from the question just now is we need to find three things, which are the recycle flow, level R on the drawing, and the production rate, level C on the drawing, and lastly, the recycle ratio. So, it's better to do the problem using the percent nitrate by shifting the water percentage to nitrate by just subtracting them from 100. We use the basis in here is 1 pound H2O, and then the unreacted reactant, we need to find the percent nitrate first, and we need to add the unreacted reactant with the basis, and then we can get the total, which is 1.6 pound. And then we can calculate the percent nitrate by dividing the total with 0.6 pound, and the percent nitrate for unreacted reactant is 0.375. Now all the compositions is in terms of mass fraction. For feed 0.2, and then for W is unknown. For SW is 0 because there is no nitrate in the product that was from evaporator. And then for SM is 0.5. For SC, which is the product, 0.96 because we just subtract them from 100. And for the XR, 0.375. So the unknowns here are W, M, C, and R.
Okay, now we need to calculate C. The systematic balance will involve only two unknowns, which is C and W. One is for desired answer, and as for W, there is no nitrate, so the term is 0. So if we look at the general equation, accumulation is equals to in minus out plus generation. Because this is a steady state process, so the accumulation is equal to 0, and there is no reaction in this process, so generation is equal to 0. So we can conclude that the equation of this process is in minus out equals to 0. So we substitute with the value, which is in is F minus with out W plus C equals to 0. So after we substitute with the value, we will get C. C is 2083.33 pound per hour. So after we will get C, then we can calculate W easily. Okay, to solve this question, first we need to calculate R. The steps to calculate R, first we need to look at the overall material balance. So in minus out equals to 0. From the diagram, in is M and out is C plus R. So M minus 2083.33 minus R equals to 0. So that is the first equation. Okay, for the second equation, we need to look at the crystallizer nitrate balance. The M we need to times with the mass fraction in M minus with C times mass fraction of C plus R times mass fraction of R equals to 0. So after we substitute with the number, then we will get the second equation. So we got two equation and two unknown. So we can solve them simultaneously, and then we get R equals to 7501.08 pounds per hour. For the third question, it asks us to find the recycle ratio. So we have already calculated R, then feed is already given 10,000. So we can calculate the ratio. R divided by F, then the ratio is 0.75. So that's all for recycle process.
Next, I'm going to proceed with bypass process. So, bypass stream is a stream that skips one or more stages and join another stream of a stage further down the process. As you can see, this is the bypass process diagram. So, the fraction of the feed skips the process unit to combine with the output stream from the unit to get the product. So, this is the bypass questions. So, in this question, it states that the fresh juice contains 88% by weight water and 12% non-volatile solids. The final product contains 58% by weight water, and the evaporator is designed to evaporate 90% of water fed to it.
Calculate the amount of bypass, the amount of water evaporated, and the amount of final product of the fresh fruit juice with a flow rate of 100 kg per minute. So this is a flow diagram based on the question given, and as you can see, this is the bypass stream. It skips from splitter to mixer. For this question, we use 100 kg per minute of feed as the basis. Firstly, we need to find the mass fraction of A at the product. So 1 minus 0.58, as it contains 58% of water. So we get 0.52 of A, 0.42 of A. And from that, we need to find the mass flow rate of A at the product. So 0.42 times mass flow rate of A equals to 12 kg at the feed. And we can get mass flow rate of A at the product is 28.6 kg per minute. And next, from that, we can count the amount of water evaporated. We use 100 kg per minute minus 28.6 kg per minute, and we get 71.4 kg per minute, which is the amount of water evaporated.
To calculate the water entering the evaporator, we need to divide the water evaporated, which is 71.4 kg per minute, with 0.9, which is the mass fraction of water that can be evaporated by the evaporator. So we get the answer, which is 79.3 kg per minute. Next, to calculate non-volatile solid entering the evaporator, we need to divide the amount of the mass flow rate water entering the evaporator with the ratio of the A to the W, which is 12/88. So we get the answer, 10.8 kg per minute.
Now, we have found the amount of water entering the evaporator and the amount of non-volatile solid that enters the evaporator. And now we have to find the amount of bypass by using those two amounts. We use 100 kg per minute, which is the amount at the feed, minus the amount of water enter the evaporator and the amount of non-volatile solid enter the evaporator, and we get 9.9 kg per minute. That is the amount of bypass. And finally, we need to find the amount leaving the evaporator. We use M2 equals to M3 plus M6, which means the amount of entering the evaporator is equal to the amount of water evaporated plus the amount of leaving the evaporator. So from that, we can get M3 equals to 90.1 minus 71.4, and we get 18.7 kg per minute. And that's it for bypass.
So this is the final flow diagram that we obtained after we solve the question.
That's all from us. Hope you can understand.
Thank you.
Bye!